come up with a formula for the area of the purple shaded part. So what you've got is a big circle, and within that circle there are two identical smaller circles. All that you're given is this distance here. This distance here is x. That's all that you're given. Okay, so this is x. So somehow, if I give you x, the distance here, what is the area of the purple bit? So come up with a formula for it. All that you're given is x. So press pause and think about it. Okay, here to work out the area of the purple shaded bit, you've got to work out the area of the big circle, well, which is the when you work out the area of the big circle here, and then you take away this circle here, and then you take away this circle here, and what you're left is basically your desired shape. Okay, so the area equals a big circle, big, and then take away small, and then take away small again, because there are two so this is a small one and a small one. So the area, the shaded bit, is a big circle. Take away the area. Take away this area here. That's this small here, and then take away this area again. So take away small here. Now big. Well, it's like your elephant, giraffe, giraffe. Because these two are the same, you can just do this. Big, take away two, small. Okay, so all we need to do is work out the area of the big circle, and then take away two lots of the small circles. Okay, let's see. Let's work out the area of the big circle. So A here equals, well, the area of the big circle, well, if you look at this, the distance here, the radius of the big circle is x, basically. Okay, so pi. Remember, the area of the circle is pi. A equals pi r squared for any given radius. So, but because the radius is x here, so we know that the area of the big circle would be pi x squared. Okay, because the radius is x, the distance is x. Okay, it could be any distance, but we just call it x. So let's just put x into here. Now the area of let's use this formula here. So now we've got to take away the area of the small circle. So take away the area of the small circle. Well, if you look at the circle, well, this is the center of a circle here. So the radius here must be a half x, but when you have x times a half, it gets multiplied to the top. So rather than seeing it as a half x, let's view it as x over 2. Okay, a half x is x over 2. So the radius is x over 2. So now let's pi r, which is x over 2. Sorry, x over 2, and then remember it exists in a bubble, because we've got to work out x over 2 first, and then we can square it. So that exists in a bubble, and then we've got to take away this circle here, because this circle here, the center is here, the radius is also x over 2. So let's see, pi x over 2 squared. Okay. So if you look at this here, this is the area of the big circle, the area of the small circle, which is this one here, and then this block here is the area of this small circle. Okay. Now let's tidy this up. This part here is actually quite complicated. So let's find a blank space somewhere and work out what x over 2 squared is. So x over 2 times x over 2. So a fraction times a fraction. So it's top times top, which is x squared. And then bottom times bottom, which is 2 times 2, which is 4. Okay, so this bit here, x squared over 4, it's this here. Okay, so let's tidy this up now. Pi x squared. Remember, this is a big circle, and then we take away the area of the small circle, which is pi. And remember, we just worked this out to be x squared over 4. Okay. So what I'm saying is that these two are the same here. Okay. And then take away, well, same thing here. Well, we know that this is this x squared over 4. Okay. And now remember, this whole term here is the big circle. This whole term here is the one of the smaller circles, and this is the other smaller circle. So now let's tidy it up. So this becomes this. Okay. This one here becomes this. Take away. Now you've got pi here timesing a fraction, so it gets multiplied to the top. Okay, let's do it as pi x squared over 4. You could write x squared pi over 4. Remember, it's like one bubble multiplying another bubble. You can actually swap them around. It doesn't matter much. Okay. So now, so basically, this here is that. Now we're going to do this one here, which is the same thing. It's a whole thing multiplying to the top. Okay, because you're multiplying a fraction. So it would be pi x squared over 4. And now there are lots of ways of doing this. Let's turn this into a fraction. So we get all the denominators to be the same, because we're trying to merge. We've got 3 blocks at the moment: big circle, small circle, small circle. Let's merge them all together. So turn this into a fraction. Pi x squared over 1, and then let's take all the others down. Hang on. Pi x squared over 4. Take away pi x squared over 4. Now, remember, all the denominators have to be the same. So let's multiply top and bottom here by 4. Okay. Leave the others. So this will become 4. Remember, yeah. So this whole thing here multiplied by 4 will be 4 pi x squared over 4, and this will be pi x squared over 4. This will be pi x squared over 4. Okay. Now that all the denominators are the same, we can merge them all together now. So here, view it like this. This is like a Liga. Exactly the same here, a Liga. Exactly the same. So here you've got 4 Ligas. Take away a Liga, take away another Liga. You're going to have 2 Ligas. Two Ligas here. Okay. And now let's rewrite this as this. I'm going to take the 2 out here. So 2 in effect times pi x squared. And then at the bottom, I'm going to write it as this: 2 times 2. So basically, what I'm trying to say is that this fraction here is the same as this. Hang on, is the same as this. 2 over 2 times pi x squared over 2. Because if I give you this here, top times top, which is 2 times 2 pi. What I'm trying to do is simplify this here. So basically, this here becomes 1. So it's 1 times this thing here. Okay. And then the 1 times anything is just the same thing. So it becomes this. This is the same as this up here, but it's just a lot cleaner. So let me continue. So from here, we're going to get to here. Okay. Basically, I'm just moving the 2 out here, and then breaking the 4 up as 2 times 2. Well, anyway, from here we will get to here, and then let's continue. And then let's break up this fraction. So it becomes this. So it becomes 2 over 2 times pi x squared over 2. 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2. 2 over 2 times pi x squared over 2 Okay, because if I give you two fractions, you're going to get top times top, bottom times bottom anyway. So I'm just breaking it up. So now this thing here, 2 divided by 2 is just 1, and then 1 times this thing here, and when you have 1 times this thing here, it equals this thing here. So this becomes pi x squared over 2. So this is our final answer. Pi x squared over 2. Yeah. So when you're here, you are done. But because you can see the 2 here and the 2 exist within this 4 here, we can tidy it up. So it becomes this pi x squared over 2. This is the same as this, but just this is a lot cleaner. That's all. So if you look at this this thing up here, the area of the purple part is actually a equals pi x squared over 2. So it's basically half of a circle in effect. What I'm trying to say is that okay, the area of the purple the area of the purple bit is the same as this area plus this area, exactly the same. You won't understand how I knew, but well, when your algebra is good, you can spot these things straight away. But by me looking at this thing here, I can tell that it's the purple bit is exactly the same as the two circles added together. Well, when your algebra is good, then you can see why that's the case. Okay.